In this video, the solution to problem number 41 that was uploaded on 15th December of 2020 itself will be discussed. This is also the right place to mention that this is a problem similar to the JAM 2019 problem uploaded as well as solved on 13th December of 2020. Well, we start the solution by remembering the definition of flux of a vector function f over an arbitrary closed surface, which is mathematically stated in equation 1. So at first, please look at equation 1. And as known to us, it is the surface integral, flux is the surface integral of the dot product of f vector and elementary surface vector, as written inside the box just adjacent to equation 1. Now, the most important thing to realize for solving this problem is that here the surface under consideration lies on the xy plane with z being held constant at the value equal to 1. I repeat, here the surface under consideration lies on the xy plane with z being held constant at the value equal to 1. And as the surface points along positive z-axis, the surface vector is at 90 degree with the x and y component of the vector function f, while the surface makes an angle of 0 degree with the z component of the vector. So on taking dot product with the area vector, only the z component of the vector function f supplied in the problem and rewritten in equation 2 will matter. So at first, please pay attention to equation 2, which redefines the surface vector stated in the problem. I repeat, please look at equation 2, which redefines the surface vector as stated in that problem. And other important findings from the ongoing discussion are summarized in equations 3 and in equation 4, which are apparently very short equations, very little equations, small equations, but they are very important for the sake of the problem. So ds equal to dx dy and z equal to 1. These are the mathematical statements of equations 3 and equation 4. And the important findings from the discussion are also summarized in the box just opposite to equations 3 and 4, that is on the right side of the figure towards the top of the board. As written, you can see surface lies on xy plane with z being a constant of value 1. So effectively the problem reduces to evaluating the double integral given in equation 5. Equation 5 as well as equation 6, which will be discussed in due time, are very important for the problem. So for the time being, pay attention to equation 5. And the procedure of evaluating the double integral defined in equation 5 is discussed in details in equation 6, which is appearing just below equation 5. So now pay attention to both these equations, which are very important for this problem. And as clearly shown in equation 6, the answer to this double integral once evaluated is 2. So rounding off to 2 decimal places, the answer should be reported as 2.00. It has been mentioned twice on the board for the convenience of the viewers. So I hope that the solution is clear to all of you after watching this video. Thanks for watching.